Hello, good afternoon. Could you please hear me?
Yes.
Okay. I would like firstly to thank you for giving me this opportunity to present my presentation. So can I start?
Yes, please.
Okay, thank you very much. So industries are increasingly with okay, sorry for this. Industries are facing nowadays challenges in the process safety management due to the complexity of operational process plant. And these presentations are intended to provide a methodology for reducing the potential risk that might affect our process through combination with a failure mode effective analysis and plan do check act. So in this presentation, I'm going to cover some of notable accidents that it's occurred in history and the process safety management in terms of ISO 31000 and what is the strategies to prevent and control these risks and framework of industrial accident and some of the prevention mechanisms. And finally, with the conclusions. So over the past decade, several accidents have been occurred that is affected significant impact affected directly and indirectly in environmental and the human health. And usually these accidents reflect the effectiveness and the efficiency of process safety management. And some of these notable accidents are occurred due to chemical exposures, fires, and earthquakes. So it has a negative impact on human health and environmental, causing a high catastrophic economic situation. Therefore, such as here some examples of some notable historical accidents in history. Therefore, a well-designed process is usually required in order to reduce the potential effect that it's affected from material flow chart, personal flow chart, emergency situations, how we can handle with chemical material through well-trained co-workers and some SOPs. And usually risk process safety management can be expressed in terms of ISO 31000 and through implementing the principle of risk management. So first we need to identify what is the potential risk that might affect our processes. Afterwards, we need to analyze these risks throughout communications and consultation with expertise, with sectors like engineers, scientists, in order to determine and evaluate these risks and to find a suitable solutions for treatment these risks. At the same time, we need to make continuous consultation and communications in order to make an improvement of any kind of the processes. Afterward, monitoring and reviewing the whole process is highly required to ensure that our solution is are kindly used for our improvement for the whole process. So this figure represented the flowchart of an organizations, like throughout continuous monitoring and evaluating the process life cycle according to a scheduled plan by analysis the data, personal behavior, and records fact. And we need always to submit a record after every kind of audit throughout a time frame. And after submitting the report, we need to make a discussion if these if our processes need to for further improvement or not. If the process does not need any further improvement, then we could submit the final report within a continuous monitoring in order to ensure that our sustainable according to the action plan. Otherwise, we need to take the recommendations from internal and external audits for improving our process system. And then afterward, we could submit our final report. It's supposed to be according to the acceptance safety criteria. And usually a good documentation is highly required. Like we need to write a documentation of every single steps and every single process that it's occur and every single failure that it's occur in our process system, because this will give us an indication what if our materials or our machinery equipment in the workplace is safety or not. This table represented a summary table for some of industrial accidents and what is the corresponding failure and how these risks is usually treated. Most of these are chemical plants and wastewater treatment. In usually these kind of industries, risk analysis usually from high to medium. Therefore, it is highly recommended to have a team of well-trained co-workers from engineers, scientists, and maintenance people that are work together in order to prevent any kind of potential risk that might be occurred. So usually the process safety management can be cooperated with process safety workplace throughout documentation inspection, and sometimes we need to make a corrective action and preventive action for any kind of failure that might be occurred through the process. And this occurred through employees' commitment, continuous maintenance, and leadership. Like all these supposed to work together, all these elements are work together in order to improve the safety of the system. One of a statistic tool usually used nowadays in industry, it is the failure mode effective analysis, in which this table, it's very simple, but the variation of the process based on a complexity. Like we need here a team, a skilled team of people are work all together in order to determine what is the potential risk that might be occurred throughout the process, the whole process from the start till the entire life cycle, and what is the potential effect of these processes and how we could reduce these effects. And we need also to write the number, the scale from 1 to 10, the severity of these accidents, the likelihood of occurrence, and the detectability from scale from 1 to 10. Like if it's easy to be detected, or sometimes some failure and some hazard are very difficult to be detected. And afterward, we could determine the risk priority number. The higher the number means the higher the risk, which is supposed to be solved first. So here we need to write all the potential risks that it's affect on the process system. So as I described first how this failure mode effective analysis is built by throughout all the possible failure, followed by describing the impact of each failure on the process and how we could prevent it throughout the whole life cycle. Here is the highest, the RPM value, depending on the severity and the urgent of correction action. And usually these risks, usually could be solved throughout writing and reviewing a standard of a procedure, shutdown, emergency, and assembling of the whole process. This matrix represented it's 10 by 10 because we said that it's the ranking from 1 till 10. So this matrix, the higher the value, the more risks and the more hazard, which here the value above 60% means that our process is highly recommended to be solved. Otherwise, from 1 till 10, from 1 till 14, that means that our processes, we are in the green region. That means that it is in the acceptable risk, and this does not have a huge impact on the whole process. As it goes a higher value, that means that our process are need to be controlled and it's supposed to be solved as soon as possible. Otherwise, it will have a negative effect on environmental and the human and economic for sure. So here, this figure represented the potential of the occurrence before implementing the failure mode effective analysis and after implementing the failure mode effective analysis. how is the value of occurrence it's decreased. For sure, the severity of any hazard risk is high, and able to be detected is high, but the potential of occurrence, it will be reduced once we already determine how these risks affected have a negative impact on the process system. For sure, it's supposed to be directly correlated to the integration between management system from ISO standards and environmental and safety management, compliant with a Plan, Do, Check, Act model, in which we need to identify what is the potential problem that usually affect throughout our process, and what is our plan in order to make an improvement from this, either by testing, either by making a validation process. And we need to make a continuous monitoring and reviewing for the whole life cycle of the process, analysis the data that it has been already from recorded. And we need sometimes to make an action for a continuous improvement of the process. Sometimes this action is from the plan do, and sometimes we need to make another correction action once we didn't get the results as we are already desired. So this an effective process usually occurred throughout making an annual inspection and continuous inspection.
Mrs. Nina, you have 2 to 3 more minutes, please.
Okay, so I can go fast here. So I would like to say that our concept for process life cycle here, we need to determine what is our overall life cycle from SOP standards according to standard regulation. And then we need to identify what could be the potential risk and management. Sometimes for any kind of a process, we need to have validation plans, overviewing for maintenance for our machine in order, and qualifications to determine the whole process life cycle. And we need for sure to have a monitoring, continuous monitoring and observation of our process is according to our scope. And this here represented a methodology diagram that it's represent the input and the output. Output represented the target of the whole process. The input is input from the raw material, and represented the whole life cycle of the process. As engineer and quality assurance, we usually calculate the desired output, compare the desired output with the target of the output. And throughout observation, we could determine that we have 3 different sectors that are cooperated together in order to control the manufacturing process, like from the equipment, machinery, process safety, education. It's highly recommended to have a well-skilled, knowledge, experienced co-workers with communications and knowledges with the regulations and budget. All of them
one more
are
minute. Just
okay.
1 more minute.
Yeah. All of them are worked together in order with the feedback by using a failure mode, effective analysis, and the Plan, Do, Check, Act, by determining what is the potential effect that it affect our process, and what is the potential hazard, and how we can determine it in order to have at the end a higher profit with a low amount of losses, economical losses. So it's very important to have an integration between a management system and sectors